Okay, good morning, everyone. Thanks very much for attending today's Urban Lifeline public seminar. My name is Jinju. I'm a professor at Southeast University, and I'm also the co-editor-in-chief of Urban Lifeline. So today we are very honored to have Professor Xiangyu Wang from East China Jiaotong University to give us a presentation on smart highway innovations, global technologies, and applications. So Professor Xiangyu Wang is an academician of European Academy of Science and also a Clarivet Global Highly Cited Scientist. He ranked #1 globally in Google Scholar Citations within BIM, infrastructure management, smart cities, etc. And among many of his great achievements, he's also the founding president of the International Society for Intelligent Construction and Manufacturing and global vice president of the International Association for Automation and Robotics in Construction. Professor Xiangyu Wang published numerous papers, and also his work has generated billions in economic impact through industry applications and collaborations with over 50 universities and nearly 100 companies across more than 50 countries. So without further ado, let's welcome Professor Xiangyu Wang and give us the presentation on smart highway innovations. Thank you again, Professor Xiangyu Wang. The floor is yours.
Thank you. Thank you very much, Professor Zhu.
And also, by the way, Xiangyu Wang, sorry to interrupt. Before you start, I think you can you minimize the panel of Teams? So yeah, great. Thank you.
Oh yeah. Okay, so can you see the screen well?
Yes, now it's perfect.
Okay. Yeah. So thank you again for thank you, Professor Zhu, for the invitation and the great introduction. And it's my great honor to have to give a seminar talk in this occasion. And I also want to thank the Journal of Urban Lifeline for inviting me as well. So basically, today I would like to share with you of my past 20 years experience on the digital technologies evolution in terms of their applications in construction and building. Well, basically building and highway construction area. And I picked the smart highway innovation. Doesn't mean that this technology only applied or will be applied or can be applied in highway only, but also can be applied in many different industry sectors like buildings and even the industry buildings like oil and gas asset and also the factory and so on. I moved to East China Jiaotong University about 3 years ago as a full-time, and now I'm running an institute of we call it the Civil Infrastructure Research Institute of Intelligent Building and Maintenance. I'm also running an international society, which I'm going to introduce a little bit later on. So, well, again, as I said, I would like to. The focus of this talk is more about the concept and about how the technology evolved for the past 20 years in terms of their application in construction. Well, now we call it as smart construction. Previously, we called it, when I was a PhD student in the United States about 20 years ago, we called it like IT application construction or IT construction or automation construction, whatever you use. And now we call it like smart construction. So what's the evolution line for the past 20 years? So basically, I want to give you a sense of how the concepts evolved and what new technologies coming out of that concept. What those technologies means to our industry sector. It doesn't have to be in highway. It can be in many other sectors, but I will give you a few highway and examples. So if you look at the smart construction, now we have a very buzzword, smart construction. We can treat it as a brain, okay, because it's smart. Okay, so if construction is an intelligent and entity or agent, then it can be somehow simulated as a brain. So for the brain, if you look at the brain, we have a three phase. Okay, so we have a this is a very simplified model of how brain works. Phase one would be, how we can simulate the activities of brain cells. Okay, so in construction engineering or in engineering context, this would be more like how we actually can, based on the next generation computer vision and sensing technologies, and then we can construct our own context. So this can actually collect engineering information in real time, and if it is precise enough, then it can be provided as future further analysis and evaluation. So once we have the brain cell, and then the brain cell, they also work with each other. They form as different regions, so we can characterize their various brain regions. So, for example, some brain region, they would be in charge of data storage. Some will be responsible for interactions, and so on. So these are all happening in engineering context as well. So this somehow, if we construct smart construction in that way, we can facilitate the lossless storage of information in various formats. So we can enable data sharing quickly between project participants, and so we can generate the optimal results by integrating domain knowledge, data, and also AI. The phase three will be the interconnectivity between the different brain cells, brain regions. Okay, so this concept can guide us to construct the comprehensive Internet of Things. We call it Internet of Things. Well, now we call it Internet of Everything. So everything can be connected together. Somehow we can enable the real-time, precise, and comprehensive digital management of the key engineering components. So we can eventually construction can be unmanned. Okay, so everything can be done by Internet of Everything. For example, whatever equipment that we're operating can be replaced by the robot, and the robot can do a lot of work for us. In terms of materials, we can use 3D printing to construct, and so on. There's a few technologies that enable that. So we talk about the brain in the last slide. So basically, my concept is smart construction actually demands an engineering brain. Okay, that's what I just said. And we have a Asian Institute of Engineering Brain, which we established about 10 years ago, but now it's merged into this the new Society of Smart Construction and Production, which I'm going to introduce you later. So if we have a brain for an engineering, right, it will be if you look at a human, you have a brain, you have limbs, you have organs, right? So brain, we think, analysis, memory, and so on, and it will give the order to our limbs, right? The foot, the legs, and hands and arms, and so on, and they can direct it to move. And then we also have organs in our body. We have skins, we have a stomach, we have heart. They all have different different functions. So so inspired by that, we can, in our engineering or any like smart construction scenario, we can also have the same thing. We can set up the same thing. You need a central AI or central brain system, so that can help you to make decisions. Now we talk about a lot of new generation of AI supported decision making. You can use that analysis, safety, or many other things like how do you actually speed up your scheduling, how do you optimize the resources you allocate to different construction activities, and so on. So we should have that. Okay, and on the construction side, we also have equipment, right? We have like a crane. We have a crane. We have a excavator. We have a lot of equipment, which also including the tools used by the workers in their hands. So we need a smart equipment, which is the interface of how we can take the order from the smart system, and then we actually apply it into the physical world. to somehow restructure the physical resources like materials. Well, it can be like concrete, water, and also including the workers. You know, how we actually restructure them and to convert the unstructured resources into the physical asset, which has a functional capability. So we also have a smart materials. Smart materials, it's more like our organs. They have a function, functional materials. For example, there's a lot of different types of functional concrete. Some can conduct the electronics. You know, some can somehow absorb the noise. You know, and so on. So these are the things we need for the engineering asset. But we also need to think about how we actually structure them. Okay, so that's the key thing. If you look at smart construction, this is the timeline I put together in the very, very early stage, back in 1970s and 80s and last century. Actually, you know, the very initial adoption of the informational, what we call it, information tools, and then in 1990s, and then there's a journal called Computing and Civil Engineering run by ISCE, and then this is an iconic milestone where the computer technology is being start to be used in construction. And in year 2000, the concept of BIM was created by Georgia Tech, and then the Automation Construction and Advanced Engineering Informatics Journal, starting from that time, published a lot of papers. And after 10 years, more talk about the digitalization. So this journal, the two journals, including the Journal of IT and Construction, you know, they heavily publish papers in that area. In about 5 years ago, 2020, the robotics and automation has been widely used. And then currently, it's more like the next generation AI for sustainable development. So that's basically a very simplified history of how the computers was initially thought to be used, and now we talk about next generation AI. So it's only like less than 50 years. If you look at the representative societies and conferences, which actually backbone the smart construction field, we look at the very early, there's ASCE, it has a few task groups and the journals supporting that. We also have an International Society of Computing and Civil and Building Engineering, which I was a board of directors for many years representing Australia. I was in Australia before I came back to China 3 years ago. And then IARC, where people know, very familiar about that, is International Association for Construction and Robotics Construction. This is I'm currently the vice president for industry for this organization. So IARC focuses on the application of automated equipment, robots, IoT, and other technologies, smart construction. Is a major academic and technical platform for exchange in the fields of intelligent construction and construction robots. The last conference was just finished over in Montreal, Canada. I think it was about two months ago. This is the organization I want to bring into your awareness. It's not new, okay? It has been running for about 11 years. But it was restructured from last year with the new name called International Society for Smart Construction Production. And the short name is SCP. We have a website. We've got a WeChat official account. If you're interested, you can use your phone to scan it. So the reason I say it's not new is I was running we call it Katrina. Advanced Technology Research Innovation Alliance in Australia. That Katrina has been established since 2015. as the Professor Zhu, the chair, introduced me, I was working with over 100 industries all over the world. Most of them are in Western Australia, specializing in highway and oil and gas and mining industry. And also those companies are the members of Katrina. So this alliance has been there for 10 years. And after that, three of us, myself and Vijay Singh, who's a U.S. National Academy of Engineering Fellow, the German National Academy of Engineering Science Fellow, Konrad Bergmeister, our three people working together to restructure Katrina into SCP since last year. Anyway, so so if you're interested, you can take a look. And we run annual conferences. This was the last year conference. We have a this year conference just finished 1 month ago, so I didn't put anything in here yet. But if you check website, you can see that. So back to the presentation. I talk about engineering brain because for the interest of time, I don't want to spend too much in here. So we have a different brain regions. Okay, so for example, the occipital lobe. Occipital lobe represented by the in the orange here is in charge of the vision sense. Okay, in our body. So in smart construction, it will be representing like the eyes on the site. Okay, so it can be any surveillance camera, any AI camera, or a UAV carried camera, or laser scanner, photogrammetry, whatever visual data can be collected on the site can be, put into this part of region. And we look at this red one, parietal lobe is more in charge of the non-visual data on the site. Okay, so basically like smoke data, if you have a fire on the site, stress data, strain data, and also position data and so on. Those are more like represented in the parietal lobe. We also have a frontal gyrus. We have 3 sections. On the upper side would be like our analysis part. So this is more like a matching our AI system, and so on. So well, this one is more explainable here, and also have a middle frontal gyrus. In this part is more responsible for processing the language communication. For example, like a BIM. BIM was first conceptualized as a communication concept, enabling the project participants to actually communicate more efficiently. And we have inferior frontal gyrus, which is the lower part of this. This one is more responsible for the motor function. Okay, so on the side would be more like equipment or tools that can be manipulated by laborers or computers to actually reshape the construction site. The light green one is temporal lobe. It's more like our memory part. So that's more matching the intelligent data storage system in the site. Okay, so smart construction. If we look at in a way of engineering brain, then it should have a 3-phase deployment. Okay, first phase deployment is paperless. Okay, so first of all, we don't need paper. And secondly, it would be automation. Okay, and lastly, it would be autonomous. Autonomous is we think autonomously. AI, can play a big role in here. Not just thinking autonomous, but also action autonomously. So we should have autonomous robots, unmanned machines, and so on. So let's look at the first phase, paperless. Smart paperless construction, intelligent construction monitoring. So the enabling technologies for paperless construction will include the BIM collaborative platform. Okay, So that's important because BIM itself is the 3D, 4D, 5D models. Itself can actually replace paper and also replace 2D. On-site digital documentation. Well, on the site, we don't really need pen and paper to take the report. It should be replaced by the tablets. Well, that's the basic bottom line, with the workers taking tablets around and put them into the digital form, and form will be integrated to the central system automatically. But a better way would be augmented reality devices, where you can actually put the digital information into the real world view. Okay. Do I have an example of that? I don't have a good example in these images, but if you're familiar with the AR, you know how it works. Thirdly, will be real-time construction data recording, okay, which is the same thing. You know, it has to be storage in a way that can be transferable and shareable with other data systems. So the advantage of that would be increasing the work efficiency, minimize human errors in taking the data, and also reduces materials waste and so on. So that's about input. And then smart construction monitoring. We also need to monitor the progress, monitor what's going on the site. So first of all is the visual perception in the wireless system. This is technologies which keep evolving. Okay, because cameras have different generations. Sensors has been there for 20 years, but now it's becoming more and more smart. They can be deployed to monitor the construction progress. Okay, for example, you can have you can put a lot of different sensors along the bridge and then the monitors. So the structure health monitoring is a domain which has been very active in that area. Drone and robot inspection, like this drone carry a sensors or camera and flying around up or below the bridge and collect whatever data that cannot be collected with the human. So this is also very important. Intelligent analysis and early warning systems. So this is more like an AI-driven analytically platform, collect data, provide the real-time alerts of structures, integrity, and also even the personnel safety. For example, on the site, you can have a camera like this on the site, and then they will construct the whatever going on the site, and then workers who actually haven't wear the PPE will be recognized by the camera and then give alert. So this makes the on-site manager job much easier. These two categories of technology has to be in place in order to support what we call as a comprehensive data support for engineering brain. Okay, so if we realize this, then all the data will be integrated into engineering brain seamlessly, so that can be support the decision making. And data-driven construction optimization. Data analysis can allow the dynamic adjustment to construction progress, to optimize materials allocation, enhancing the overall intelligence of management. Give you an example for the highway bridge. The highway bridge example, this is one was done with a local Chinese company, basically to simulating the full-scale bridge, and there's a surrounding environment. So sometimes it's a foggy day, sometimes it's a raining day. So those environment, and then integrate with the camera or sensors, multiple camera vehicle tracking. So whatever vehicle actually passing the bridge, like here, it will be tracked automatically, and also the what do we call it? The driving route or itinerary will be captured, and then we captured in a digital twin, so we can analyze, their driving behaviors and so on. The application we use is well, how do we actually, as mentioned, if they change lane, sometimes, you know, the heavy truck, they are only allowed to drive on a particular lane. They cannot change, but they change. So use camera, you can capture them, violate and give them ticket or give them warning. We can also have automatic global camera layout for a bridge like this, 2 or 3 kilometers long. You cannot afford to put a lot of cameras on it. So we actually minimize the number of cameras put on the bridge, but the scale can coverage the entire range. So that's also important. We can also integrate the real-time vehicle and their weight on the bridge and the position, and integrate them with the bridge health monitoring models and also sensor data. So we can do a lot of real-time finite element analysis and so on. This is already a product, the digital twin platform. It's commercial products. Now it can be used. The accuracy of that can be increased by 35%, and we work with a few local companies, and this is the 10 million RMB rand can be saved every year, you know, for the maintenance cost. Anyway, so phase 2. Phase 2 will be automated. So intelligent construction plan plus automatic generation of schedules, cost, and resource plans. So it's based on large models and deep reinforcement learning, and large model will leverage large scale data, deep learning algorithm, and deep reinforcement learning. We combine the deep learning and the reinforcement learning, and also deep neural network and so on. So putting these two models together, we can create 2 set of applications. Number 1 is intelligent construction plan generation. So again, automatically generate construction plan for you. Okay, totally driven by AI. If you give them boundary data. AI large model combined with construction design parameters, geologic conditions, construction standards, other factors, and so on. So this preliminary construction plan will be created. Okay, and these plans will be compared automatically, give you a best solution. And then we can use the deep learning optimization to select the optimal construction plan. Because once you have a plan, and then you can detail the quality, cost, and time information with a good balance, which is create the second set of application we're talking about here. So you can have automatic schedules created, which will be scientifically optimized and rationally sequencing of the data task. You can have the budget to be created automatically, and also help the managers in effective cost control. And of course, the resources can be automatically generated as well. The last phase, which will be the future, I think, will be the autonomous. Autonomous also have 3 sub-phases. The first phase under autonomous will be how human and robot can interact with each other. So human tells robot what to do. Okay, that's what we're doing now, right? So if you have a construction robot on site, you can direct operate it or remotely control it, but you have to give order from a human being. Robots have to rely on human operation and command at this phase, and humans can be responsible for decision making and control. Robots just do the thing, do the work. So humans can utilize the engineering brain, which we talked about earlier, based on the AI and sensors to control robots, so that we can ensure the precision efficiency. Robot is very precise, right? Like a robot arm, when they're cutting, when they do the cutting job, laser cutting, you know, they're very precise. And the humans can adjust robots' behavior through a control panel and mobile devices. Okay, so this is a human-robot interaction, not two-way interaction, but more like human give orders to robot. The second phase after that will be robot-human phase. Okay, the core here is robots will automatically perform construction tasks through engineering brain and provide the feedback to humans, and human can examine or can somehow review their work and then give them further instructions. So intelligence support system, robots can provide the work guidance and optimize suggestions to human. The human give them feedback. Okay, so the robots can perform complicated tasks such as structure analysis in smart construction and guide the human in making decisions. So this is more advanced. You have imagine you have so many robots in your site, and then not only to do the work like in the first phase, but also they are your ears and eyes or hands. They can actually collect all the necessary data from the site, right, and then give it to you, and then you analysis. So you can adjust. You can decide the quality, pass or not. You can adjust the cost, control the cost. You can adjust the resources you allocate to different robot for them to. Some robot needs to speed up their work. Some robot can slow down a little bit, and so on. So overall, you still want it to be, less time, less money, and better quality. The last phase, which is the ultimate phase in autonomous, will be robot phase. And the core here is robots will fully rely on the engineering brain, or we call it intelligence system, right? And then they will somehow coordinate and execute the tasks in between. So you take the human out of this loop completely. So no human brain here. But of course, before you do that, human and human knowledge already embedded into the engineering brain system anyway. So in here, the engineering brain can facilitate the collaboration among robots and the real-time optimization of task schedules, fault prediction, and so on. Okay, so robot here will completely replace the human labor and the human engineers. So labor is workers. Laborers, they are hands, they reshape things. Engineers, they think. So both can be replaced. Machines is there already. So machines just need to be reconfigured into a robot. And the robot can not only think, but also can order itself to somehow function as a construction machinery. Anyway, so the task, and as an example of that would be multiple robots can work together to complete tasks such as smart construction assembly and installation and so on. So this can be much easier to be realized in a factory scenario. Okay, so prefabricated workshop will be more readily to adopt this, but gradually it can be applied in the site as well. I'm pretty much to the end of my presentation. This is a picture not created by me, but it's an old picture showing the evolution of AI. So how the AI actually evolved since 1950s when the concept was created, but now not just 2020, but 2025 with the new generations of AI. So if you look at their history and think about if we have a similar version of AI in our construction, okay, so AI in construction or AI in civil engineering, whatever you call it. So if you look at what the future roads we want to take, and we need to look at what the AI is coming from. So AI in civil engineering can take this very similar evolution route. So this actually gives us the ideas. Okay, sometimes we need to go to robotics stream, sometimes go to heuristics, sometimes go to neural. So why these sub branch come from, and why some sub branch in a certain time they actually merge and become a stronger branch. So this is something I leave it to you to think about. Physical world, cyber world. If you look at the AI, digital twin, they're all in the virtual world. And the physical world is work that world where we're working on. That's the world we're reshaping, restructuring. Okay, so there's two balance. Okay, sometimes you take physical world, take human out of the loop, right? Let the AI to think more, and then you actually, have a somehow different balance. So for me, I would like to see more emphasis on the use of information world, virtual world tools like AI and so on, rather than rely on human knowledge and experience heavily. So these are the some of the future directions for how we do research in engineering brain for construction, but not limited to this. For the interest of time, I'm not going to the details. There could be much more things to be worthy to work on. Okay, so I was told that I have about 35 minutes for my talk, so I probably stop here and then to see if any questions. Okay, I give it to you, Professor Zhu. I finish
Thank
here.
you. Yeah, thank you so much, Professor Wang, for the great presentation. It gives us a big picture of the global technology applications, the history and current status and future of smart construction. Any questions? If you are online on Teams, you can unmute yourself and directly talk. If you are on WeChat live stream, you can maybe put your question on the chat box and we can read your question. Okay. Any questions on our participants? Check. If not, I have a quick question, Professor Wang. So you're talking about the three phases, right? And what do you think, especially the current biggest challenge in the current? We're at phase 3, right? We are moving toward. We have first the robot-human interaction, human-robot interaction, and now robot-to-robot interaction. What do you think the biggest challenge now? And also, what do you think about maybe more forward-looking question? What do you think about the next phase? In the future, what do you think we are going to have and as a vision?
Yes, thank you. That's a good question. For the 3rd phase, we are pretty much in the 2nd phase. The 1st phase is already completed, so that's represented by this Internet of Things and Bing, while those two areas already mature enough. So 2nd phase, now we're working on with the AI things, and AI tools are very powerful, which is good. I'm not very concerned about technology, enabling technology itself, because it's every day it's happening very quickly. I would say the biggest challenge for us is the construction industry itself. I think construction industry, not just in one country, but in all countries, they are very conservative. They are very case by case. You finish one project, then move to the next project. So the industry, what do we call the scenarios or characteristics itself doesn't allow the trial of new technologies. It's not very friendly and supportive to new trials of technologies because it costs money, right? It costs time. You need a group of people who can be trained to use technologies so that can become standards. And also it has a risk because it might interfere the construction operation itself. So I would say the biggest challenge from our own industry, not the technologies, is a management problem. It's also a mind-setting problem, because mind-setting, well, is sometimes needs time to change. So that's the biggest challenge. Budget is also a challenge, but budget will be related to mind-setting. When I was in Australia, we have we created a very good model of if they invest, right, and then they can say invest X dollar, they can actually save Y dollar, right? But still, there's a lot of pushback from you know, from the most of them from the unions, you know, because they don't want to change. Or the change is probably too radical, not affordable, and so on. And the management, they don't want to invest too much money, right? And so there's always, you know, a problem. So technology is always there, right? And you have so many smart brains, you know, and then there's so many good papers already published, which proved some technology can work in some construction scenarios, but still nobody wants to, you know, and use it comprehensively. But they can do some trials on the spot, but not comprehensively throughout all operations, which I think will take time. In the future, we will be better and better. Yeah. So the other question you said, you mentioned is what's the future will look like? I think the future, if we talk about like maybe 50 years or 100 years later, I would say in the future would be engineering brain will dominate everything. Okay, so you have we don't need construction workers, we don't need engineers, we don't even need designers and architects, which is a little bit you know, terrifying, I know, but you know, construction would be the one of the most latest industry sector who will be, you know, something like that. There will be a lot of infrastructure sectors more advanced of us, ahead of us to reach this point, but construction will be the latest. Yeah, so I would say that would be the case in the future. Design, thinking, management, and so on will all be replaced by AI. It's just a matter of time.
Thank you so much. I completely agree, and I think it's maybe you know, lead us to some more conversation discussion. It's very interesting, as you mentioned, technology, sometimes it's the easiest link, but then how you change the mindset and how you actually apply the technology. Also, as you mentioned, in the future, when everything is robotics, it's maybe terrifying. So how people accept this new future. So, you know, it's actually a very interdisciplinary problem, like technology, policy, human decision making, and your perception about the world. You know, I think today's presentation opens some, you know, opens a door for us, but it definitely to more interesting discussion and, you know, thinking, you know, collective thinking of all the disciplines in the future. Thank you so much, Professor Wang.
Yeah, pleasure.
Great. So we are, you know, almost towards the end of today's session. If no more question, thank you again, Professor Wang, for this great presentation. And if you have more questions and want to connect with Professor Wang, you can, you know, maybe contact the journal, and we can definitely also follow up with Professor Wang and hopefully continue this conversation we started today. Thank you so much. And thank you all for participating in today's presentation. Thank you.
Thank you. Thank you.
Bye-bye, everyone.
Bye-bye.
Bye.